Namaste, my name is Vio and welcome to our series of discoveries. Here I'm not talking about a discovery that has happened in laboratory. I'm talking about the discoveries which did not happen in laboratory. So what are those discoveries? Let's find out. The first discovery that we want to discuss, and today the point of discussion is about trigonometry. It's a very fascinating topic because it has two interesting sides about trigonometry. One side is trigonometry, and the discovery of trigonometry is extremely interesting. No one talks about it. No one. At least in my life, I've taught mathematics for 17 years. I could not find any textbook, any book talking about that, and I don't think it is found on Google as well. I don't think there's any other mathematician or a scientist in mathematics or a researcher in mathematics has talked about the discovery of trigonometry. That makes it far more interesting, according to me. The second part of interest is trigonometry is a very hated topic. There are a lot of students who don't like this at all. There are a lot of friends from my school, from my college, and they often ask me, you teach mathematics, so why don't you tell me? In our school and in our college, we learned about sine theta and cos theta. We still have not figured out what is use of that. So could you tell us that? All of this is, forming a big jargon as the whole nonsense about trigonometry is no one talks about how was it discovered, what is the significance, what is speciality about it. And the second part is you're just asked to remember the formula of trigonometry, which is not going to help anyone. So we're going to break the pattern and we'll just say trigonometry, discovery of trigonometry. That will actually help. In my experience, I found that if I know how was one thing discovered and what is the speciality of that thing, then that is the biggest help that I can get to learn, to practice, to use, to utilize, to implement. So, without wasting any time, let's start with the discovery of trigonometry. It did not happen in the modern era. It's not like industrial revolution or any recent mathematicians or Newton or before that maybe Aristotle. It's not that. It's not in that phase. Trigonometry was discovered a long time ago, like in an ancient long time, like a 2000 years ago or 2500 years ago. Some even date back to 3000 or 3500 years ago. There were two places where trigonometry was first discovered, or the evidences are seen in two different places. One is India. There are a lot of scriptures, there are a lot of written, documented things which refer to trigonometry, refer about trigonometry, write about trigonometry, and the pyramids, Egyptian pyramids. It is impossible that you build those pyramids without understanding of trigonometry. Whatever I studied, little bit I found, I could not find any written scripture of Egyptian scripture written about trigonometry. But if you study their pyramids, it is impossible that they can build those pyramids without understanding triangles and trigonometry. I'm very sure about that. So I think Egyptians surely knew about trigonometry. They knew about triangles and the properties of triangles. And I'm sure the Indians knew about it as well because Indian documentation is actually talking about that. But how was it discovered? I'm telling you, I'm not a great student of ancient scriptures. I am not selective, but only what I like. I take that part and I go deep down researching on my own. I don't read the scriptures entirely. Even if you give me a poem today, maybe ancient poem or today's written poem, I'll not read the entire poem many times. Most probably it will not happen. What I'll do, I'll read that, and there's something that clicks, and that part will make sure that the entire poem leaves me for a long time. And in my life, whatever be the significance of poem, that will come out. So that is how I live my life. So I cannot claim about where it is written and where it is not written because I am never the one to talk authentically about what is written in the scriptures or what is written in the ancient books or documentations. But I can tell you with my own process, I can tell you how was trigonometry discovered and many other things. We are just talking about trigonometry as an example. Today is the first test case of that. So let's see. Let's wasting any further time. This is ground. On the ground level, standing is a man, and with him is his son. Let's say the son is at a distance. The man and his child, why son can be daughter as well. Man and child. His son here. And the light. This part is the shadow. It is obvious that the length of the shadow in this case, in this particular case, the length of the shadow and the height of the man is same. The length and the height is same. But you know, interestingly, the same thing happens because the sun is so large that the light is coming parallel. And even for the boy or even for the kid, this and this is same. The shadow and the length is same. Now, initially, it is obvious that anybody would be thinking, okay, this is my height and the length of the shadow is looking almost the same length. It is almost the same. So, the shadow is as long as or as big as I am. But then, a couple of hours later, you will find out that the sunlight has slightly bent and the shadows are lengthening and the shadow is longer now. So the man realized, okay, the length of the shadow is not always the same. My height is not changing, but the length of the shadow is changing. It does not need any measuring tape. You don't have to sit down with a scale or a tape. It is very easy to see. You just see it and you know it. So this distance is variable because this sun is going to change its position, relative position. And because the relative position of the sun is changing, the angle will be different. And because of that, this angle will change. And because of that, this distance is changing. At that time, man had no knowledge of this. He only knew that the length of the shadow is changing. But he noticed that at a particular time, at one particular time, when the man and his shadow were of the same length. The shadow and the height are equal in length. And in some other case, he also noticed that at the same time, for his kid, even the kid's shadow and the kid's height is same. Now this is interesting. When the sun is at a particular position in the sky, then the shadow of the man and the height of the man and the shadow of the man is same in length. At that same time, when the position of the sun is just the appropriate, just the special one, then even for his kid, the height and the length of the shadow is same. Let's say you take a tree, there was a tree somewhere. Even the tree would cast the shadow of the same height, the length will be just the same. Now if we extend this, it was very peculiar. The man was interested. He thought this is interesting. After some time, as the sun started to set, and with the setting sun, the shadows are lengthening, they're making longer. So at some instant of time, the man saw that his shadow is double the length. So whatever be the height of the man, the shadow is double that height. But then the man observed, it is also the same case for his kid. If this is height of the kid, h, small h, then this will be 2h, double. So the man was very interested in this and he decided to draw some sketches like I'm drawing here. What exactly did he draw? The same thing, but I'll just show how the entire process, we just walk through that. So the man said, this is my height. At one particular position, the shadow and my height are of the same length. I just completed this triangle. This is the path of the sunlight. Sun ray is coming in this path. At the same time, even this kid had the shadow having the same length as his height. It was obvious that this shadow, the length of the shadow, will change if this direction of the sunlight is changing. Because if it bends, then as the sun sets down, he saw that for the kid, the shadow becomes longer. Even for the man, with the setting sun, the shadow became longer. It wasn't directly this long, it gradually grew. And a point came when it is double the distance. So it is twice of it, it is h. H. And so on, so on, so on, so on. From here the man saw and he checked the height of the tree, the length of the shadow. He is not measuring everything accurately. He is not interested in the measurements. He is understanding the existence of this entire phenomenon. And he realizes if the sun goes down with the setting sun, as the position of the sun descends down, this ray of light is going to become more flatter. And as it becomes flatter, 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 as the point becomes flat, more and more flat, this height will not change. So this distance will change. And this shadow will become longer. Clearly when the sun is right on top, there is no shadow. The shadow is length 0. So he started to say, if this is the angle made by the vertical and the line of sunlight, then the angle between the sun ray or the sunlight with the vertical, as this angle changes, this shadow's distance changes. There is one more observation. So I'll just write this observation. Angle between sunlight and vertical is a special thing. He realized. What is this speciality? We'll talk about it in a couple of minutes. So he realized that this angle is special. There is one more thing he realized. Second, at any point of time, if the ratio of his own height and the length of the shadow, if this ratio is 1, if the length of shadow is equal to his own height, then at that point, even for his kid, the length of the shadow is equal to the height. Even for a tree, the length of the shadow will be equal to the height. Even for anything, you hold a stick on the ground, even the stick will cast the shadow of the same length as the height. So this height upon distance or height upon length is going to have the same value if this position of the sun and this angle is not changing. So he realized that the ratio of height upon length is constant if the position of the sun and the angle, if the position of the sun is same, then the angle is same. Then this angle is constant. If this angle changes, then this ratio will change. And the third thing he realized that If the angle is changing, then it means that the above ratio will also change. The primary realization here is my length of shadow, the length of my shadow is equal to my height. But it is not, I cannot say that the length of shadow is 5 feet 7 inches. I cannot say that because for a kid the length of shadow will be just about a couple of feet in length. Because the kid is shorter. But you got to understand that the length of shadow is equal to height. And that came to understanding that we should not be talking about only the length. We should be talking about the ratio. This is where the students and almost everyone whoever has problem with trigonometry, they have this problem because of just this reason. If needed, we'll write this again, but let me make this point clear. We often have a problem saying that if in a triangle, if this angle or this angle is changing, then we are interested, we easily understand one distance or the second distance. But we don't understand why in trigonometry it is always like something upon something, like A upon B or B upon A or A upon C or B upon C, something upon something all the time. Why do we always take the ratio? Because you understand, if it is at 45 degrees, the sun is right at 45 degrees. Supposedly, the sunrise is at 6 a.m., sunset is at 6 p.m. Then, right at 12 o'clock noon, the sun will be overhead. So, at 9 a.m. in the morning or at 3 p.m. in the evening, in the afternoon, 9 a.m. or at 3 p.m., the sun rays will be exactly at 45 degree, right in between the 90 degree and the 0 degree angle, exactly at 45 degree. And at that time, this distance, height and this length L will be equal. But this will be equal for everyone. But for a tree, the height is different. So the length of the shadow will be different. For a man, the height is different. So his length of the shadow is different. For a kid, the height is different. So the length of the shadow is different. So what can we do? We only have to do one thing, that will say the distances are changing because different people have different heights. And the height is not going to change because of the position of the sun. Length of the shadow is changing. So why don't we worry about just the ratio? Let's take the height upon length. So we will take height divided by length. Or we could do the other side. Sometimes it helps as well because we need this angle. So we take length divided by height. Because I was interested in the opposite upon adjacent side. So if we take this angle, then the side in front of the angle is L. And the side next to the or adjacent to the angle is H. L upon H. But then there is opposite thing possible as well. Now for the same angle I can say, I will take the adjacent divided by opposite, so I will get H upon L. So these two both are trigonometry, they both are ratios. Something upon something is called as a ratio. But these two ratios are different, so they must be given different names. They are not just these two ratios. I could also take this is, let's say I take this distance as R. I don't have any meaning here, I am putting random variable here, random name R. So I can also have R upon H and I can have H upon R. I can have R upon L and L upon R. So there are 1, 2, 3, 4, 5, 6 trigonometric ratios possible. So because there are 6 ratios possible, we'll give them 6 different names. Now, I'm not interested in teaching you the techniques of trigonometry, technicalities of trigonometry in this discussion. I am saying the origin of trigonometry was something like this. It happened by just simple observation that my shadow is this long and someone else's shadow is how long. And then we realize that because someone else is either taller or shorter, that's why the shadow is long. But the ratio of height and the length of the shadow, this ratio is always constant at a given point of time for any person. You take one person, the length of the shadow divided by height will come some value. For other person, it will come the same value at the same point of time. You can even take the tree, it will always be the same. Because the angle of the sun is such that no matter what the height, the distance of the length of the shadow divided by the height, this ratio will always be the same provided the sun is at the same position. Once we know that, we understand that how was trigonometry invented, provided the angle is same. We say that now. This is what trigonometry is, right? Supposedly this angle is 30 degrees. Then we say this is A, this is B, and this is C. Then we write AC upon BC. AC upon BC is equal to, supposedly I draw this line as well, parallel lines P and this is Q. Then I'll write AC upon BC is equal to PQ upon BQ. How do I say this? This is very, very, very simple. It is just a very simple thing that you can understand is because this angle is 90 degree, this angle is 90 degree as well. So in the whole triangle ABC and triangle PBQ, this angle is same. And if this angle is same, then the ratio of opposite upon adjacent will be same, no matter what the other distances are. But how do we know this? How do we know if the opposite upon adjacent is same? We know this because if this is the sun, this is the man, then his shadow then this opposite, this angle, opposite upon adjacent, this ratio, and if the man is shorter here, then this ratio, opposite upon adjacent, will be same. That's why at 3 p.m., naturally when the sunlight is coming at 45 degrees, we have the length of the shadow equal to our height. So the ratio is 1. Length of the shadow upon height or height upon length of the shadow, the ratio is 1. But it is equal to 1 for everybody in this world. Even for a kid, even for a mountain, even for a tree, it is equal to 1. Because the angle is same. If the angle made by the sun with horizontal or the angle made by the sun with the vertical, if that angle is not changing, then the ratio will not change. Out of that understanding, the trigonometry was originated. The trigonometry was generated because of that understanding that if the angle is not changing, then the ratio will not change. And this is what trigonometry is. When we were in school, and if we were taught in this manner that it is not about the distances, don't worry about this upon this, just understand whenever that particular angle is constant, then the ratio of height and the length of the shadow is never going to change. From there, man realized that angle is associated with the ratio of sides in a triangle. Once you know this, after that the trigonometry is very easy. I taught for 17 years and I know that the problem in mathematics or physics or chemistry or anything is about the start. The concept is not known. Students do not know why this. Why? Why is it always like this? If you take ratio here, why do you take ratio? If you mention angle here, why do you mention the angle? What is the reason behind that? This, if you do not know, if you do not tell the students about the origin of this, we are starting on the note of confusion. And please don't mind, but I can bet on this. 99.99% of teachers of mathematics don't know this. They have no idea where the trigonometries come from. They make a huge show as if they are teaching trigonometry, they are doing something great for humanity, they are enriching the students. They tell all kinds of lies. But they have no understanding of where has this come from. See, if you don't know where has this come from, if you don't know how The first human being who understood trigonometry, who understood the logic of the ratios of sides. If you don't know how did he come to this conclusion, it is obvious that you're confused about it, and you only make sure that you replicate the confusion. In every book that you read, in every lecture that you attend, in every class that you go to, in every movie that you see, what is told in that, you will know that as information or understanding. But the confusion that exists there, that confusion will come to you as an unknown Xerox copy that you're carrying. You don't know about that confusion, but the confusion will come to you. That is why it is best that we have teachers who have lesser confusion and they can tell the students about everything. I'm so happy that India knew this 3,500 years back. This is like, what more can there be a reason for an Indian to be proud of? All right. I hope you understood this. I hope you liked this. If you did, please share this video. Please like this video and share it with your friends. Subscribe to my channel, please, and press the notification icon. Thank you.